Hello, Eric Larson here. Got a new video. This is another one in a series of videos about solid modeling and 3D printing, and this one is about interlocking parts. So, Fusion's the trademark of Autodesk Incorporated. It's a wonderful product. We're going to talk in this video about how to design parts that fit together. We want parts that will fit together easily to promote assembly. And then maybe we can glue them together once they're in their final orientation. But we want them to kind of stick together when we stick them together. And the target audience for the video is someone who's relatively new to solid modeling and the use of Fusion. It's expected that you know how to create sketches and do lofts, and you can see the other videos in this series if you need to learn those things. So, mechanical engineering theory. Now, I'm not a mechanical engineer, but I've studied some of it, and maybe you have better insight, so I look forward to hearing your comments. But when we have two parts that fit together in a concentric fashion, there's several different ways that it can go. And if you visualize a smaller pipe fitting into the inside of a larger pipe, that's what we're trying to do. And you can have a clearance fit. The smaller pipe slides easily into the larger pipe, but it might come loose if you let go of it. You can have an interference fit. The smaller pipe is a little bit too big, but you might somehow be able to pound it in there. If you heat up the larger pipe to expand it, you might be able to shove it into place. You have to force it. There might be some deformation of the parts. It's basically possible, but it's difficult. You can have a transition fit where you design parts which might be either too big or too small, depending on the variance of your manufacturing process. And you won't really be sure what's going to work until you try it. And some might be too loose, some might be too tight. You can also have a line fit, and this is where parts are exactly the right size, and if they're perfectly smooth and well lubricated, they should fit together. But this only works if you have perfect manufacturing. You're almost never going to be able to build something with perfect tolerances, plus or minus 0. So practical reality. So your ability to make parts that fit together is going to depend on how accurately you can make them. If you can make parts with high accuracy, they will fit together very smoothly every time. So my 3D printer is a Creality Ender V2 Neo. Can print parts with a precision of 0.1 millimeter. That's a tenth of a millimeter, which is a vanishingly small thing. It's a very precise machine. So if we're making parts that are printed vertically, that is, if you imagine a pipe, it's on its end, and as it gets taller, as you print it, it gets taller, and the open end is at the top. So if you're making a part vertically with no need for support, you can in fact hit that level of accuracy pretty much. So if you have smaller concentric parts that are in the range of 20 millimeter diameter, a difference in diameter of 0.3 millimeters will give us parts that can be pressed together without deformation and which will hold together with friction. So if you're making parts with horizontal orientation, that is, maybe your pipe is laying on its side and the two ends are kind of open, they're facing left and right, and you've got to have internal support during manufacturing or your printing, all bets are off. You're going to need to have larger clearances to ensure that the parts will fit because they aren't quite as precise. If you've got support, you've got things drooping a little bit, your concentric parts might not be perfectly round. So, what we want to do is create parts that can be fit together with relatively slight pressure, no deformation of the parts. We want there to be enough friction that the parts can remain connected if we let go of them, but we can pull them apart and put them back together. So, as part of this exercise, we're going to design and print some simple parts that fit together in concentric fashion. Basically, a smaller pipe that fits inside a larger pipe. We'll make a very simple design that we can make two copies of and see how the two parts, which are identical, see how they fit together. So we'll jump out of slideshow and jump into Fusion. This part is our interlocking part. And what you can see is that it's got, if you kind of orbit view, you can see that it's kind of got a small section which will fit inside the larger section. And the edges here are kind of rounded off. We chamfered them, and the bottom edge is rounded off so that it fits in smoothly. And this part is not very tall. I mean, obviously, if you want to have a pipe, you would probably extend the smaller section and leave the bigger section at the end, and have a long section which is smaller diameter, and you could fit them together at the joints. So if we look at here is an assembly that shows how the two parts fit together, and if we right click on our joint and animate the relationships, you can see how they slide together. They just slide in and out, and there's not a whole lot of complexity to it. Okay, so we'll hit escape to stop the animation. Okay, now I will show you how to quickly design these parts. It should be, maybe this is very obvious and simple to you, but it's not. It should be a relatively fast exercise. So here we are in the XZ plane. We hit the create sketch. We will create two circles which are centered on the origin. We hit enter, press D for dimension. The inner circle will be diameter 20. The outer circle will be diameter 20. Okay, let's see. We want to make sure that we got this right. 23.7. So it's just. Oh, did we get this right? Okay, here. Okay, hit escape to get out of dimension mode. Okay, so it's 3/10 of a millimeter smaller than a 24-inch diameter circle. So we hit finish sketch. We go back to home. If we click here, hit E for extrude that to 10. New body. Okay. So here we have a pipe it's the interior dimension, the interior diameter, inside diameter is 20. The outside diameter is 23.70. Okay, so we go back to our plane. We pull down construct. We want an offset plane, and we want that plane to be at distance 15. Okay, there we go. We can turn off visibility of this body. We select our plane. Click. Now we create a sketch on the plane, and we'll create two more circles. Okay. Check. D for dimension. The inner one will be 24. The outer one will be. Oops. Cancel. What's going on here? Okay. The inner diameter is. Oh, wait a minute. Okay, I didn't want that. Okay, sorry about that. Okay, the inner one, D for dimension, the inner circle will be 24. Okay, and what happened to my outer circle here? Is this it? This is strange. Okay, anyway, well, I want a circle which is outside of it. Hit D for dimension. I want this one to be 27. So, as you can see, the walls of my pipe are 3 millimeters in diameter. Hit finish sketch. Go back to home. If we click on this surface, hit E for extrude. Extrude that up 10. New body, that's cool. Turn on visibility of bodies. And now you can see that we have two pipes that kind of one above the other. And what we'd like to do is join those two things together using a loft. Okay, and we can close off our browser here, and if we select this surface, pull down create loft, then hit orbit, and rotate so that we can see our, and now we hit escape, and now if we select here, we have our two profiles, and we would expect this to work. But for some reason it doesn't actually work, and it's not clear to me exactly why. We're getting an error message saying cannot create the tool body for the loft. I don't quite know what's wrong. I would expect this to work. If we hit cancel, we're kind of back to where we started. So how do we work around this problem? I would say I can tell you what I'm going to do, and that is I'm going to delete these bodies that we created, and I'm going to turn on visibility of sketch 1. I'll select the interior. I hold down the control key. I select the outer circle. I hit E for extrude. I extrude both bodies to 10. So there we go. Now I can turn this one off. I turn on visibility of sketch 2. I do this about the same thing. I click the inside. I click the other profile here. I'm holding down the control key. Okay, now we have multiple selections. We have both profiles selected. I hit E for extrude. I'll take this one up 10. There we go. So now if we turn on both bodies, you'll see that we have two bodies selected with a gap in between them. And in this case, we hope if we select this face, pull down create loft, okay, hit orbit. We need to hit orbit. We rotate around so that, and then we hit escape. Now we'll select our second profile and hit OK. And if we turn off sketches, what we see is that we now have a solid body that has it's basically two cylinders stacked on top of each other that are connected by a region that merges the changes of diameter. So if we turn on visibility of sketch 1 and turn off sketch 2 and turn off bodies, if we select this interior profile, hit E for extrude, and say that we want to cut, and say that we want to take it to 25. Okay, 25. Okay, and it says it can't find it, but it's only because we've turned off visibility to the bodies. If we turn it on, then it can make the cut. Okay, so now we cut out the small volume, and what we want to do now is we want to turn on sketch 2, turn off bodies, and we will select the larger body, hit E for extrude, new body, cut, and we want to make this one should be 10, and we will turn on visibility of bodies. There we go. So now we've, and if we want to make this easier to visualize, we'll turn off sketches, and you can see that we've now created our sample part, and that it's got the two different diameters. If you look down the center, and it's what we want. So what we will do next is we want to select this ring. We will do a fillet. we'll say that we want it 2. We want it to be 2, and we'll select this one, and we'll fill it, and we want to select that one to be 2 millimeters, and say okay. And now we've got about what we want. We think that this will work, and we can change the appearance of it. Let's go for my favorite, which is green, since I have green filament in my printer. A lot of the things I choose to make a color, I make them green. So there it is. So that's pretty nice. Okay, so we can close this, and now we've got our part. We can save it, and we'll call it just part. Okay, it's a part. Okay, and now if we want to, what we want to do is print this. Go to 3D print. We will say print utility. We want 3MF. We select. We can say okay. And now I'm going to bring up Cora, which is a little bit slow, but I want to try and emphasize what the appropriate orientation for printing this part will be. And we want to print it basically the way that we're looking at it. We want the base of the print bed to be on the, I want to say that should be the XZ plane. And we want it to print as we go up toward the y-axis. So if things are working normally, Cora is busily launching. It should be here soon, one of these days. We'll get Cora going, and we can see that we can see how to orient this part to print it. Well, we're waiting for Cora. Not totally sure it's happening. Maybe we should try that again. Not sure. 3D print. Okay, we selected the part. We have print utility, 3MF. Okay, we say okay. Okay, here we go. Now we've got Cora coming up. That's good. I don't really know how important this is, but what we want to do is make sure that we have oriented. Okay, we select, we arrange, and now what we want to do is perform a rotation. So we rotate that to 90 degrees. And then we hit the move, we drag it up, and release it. Okay, cool. And now you can see that this part is oriented in a way that that will cause it to print out very nicely. And supports are on, but we won't actually need support for this for what we're doing, because the angle is such that the angle of this interface between the two cylinders is steep enough that it will work just fine, and we won't actually get any supports with this design. If we preview it, we can see that we have a brim around the bottom, but no supports on the interior. And you could print this with the large end up. Just as easily if you wanted to, but I print it like this. It works fine. Okay, so I think and I've actually printed these parts, and I find that they fit together quite smoothly, and you can fit them together. They stick together, and it all works pretty good. So with the 3/10 of difference. So another thing that you might do, or which I did, was I I tried a little bit different approach. You can, if we double click on this one, this is an example of a different approach that you can take to make an even more firm interlocking part. And I think you can very easily visualize how these parts kind of fit together, and then you twist them slightly. But what I found was that this little knob was too small. It broke off quite easily, and that also this part you tended to get some splits or fractures in your parts. So I think if I was going to try and use this technique, I would need to have a little bit thicker wall thickness. Probably need to have walls that are thicker than 3 millimeters, and I would need to have a little bit larger diameter on this little knobber. And but I think with a little refinement, this technique could be made to be something that's quite good. But my first try, it wasn't so great. All right, so we will jump out of Fusion. We will close Cura, and we'll go back to our slides. Go back to slideshow. Okay, so here's a recap. So we made some simple parts, we printed them, we found they fit together nicely. We had to work around Fusion not working exactly as we might expect it to. I basically expected that loft to work. It's not clear to me why it doesn't work. I don't know, I'm reluctant to say it's a bug, but it looks like a bug to me. And what we see when we build the parts is that a 0.3 millimeter difference in diameter works great for concentric parts when they're printed vertically and they are about the scale of small parts. 20 millimeters is the part that's smaller than an inch. These are small little toy parts. And we looked at another way to join the parts, but with the knobs and slots and stuff. This approach needs a little bit more work to make it into something that's practical. Okay, well, that's all there is to this video. Hope you liked it. This is Eric Larson signing off from Silicon Valley. Stay tuned. I'm trying to figure out what to do for the next video, but I hope to have it ready pretty soon. All right, see you later. Bye.